So for this explanation of the Chapter 6 problem set, it's not going to be as detailed as my last video because the math is not nearly as hard. And so I don't need to go through and show you how to do the entire problem each time because it's just simple math and algebra. But I will set you up conceptually for it. And the first thing you'll notice is that I've given you the answer for the first one right away. And that's because you're going to use this value, 3 times 10 to the 8. Well, it's hard to read there, but I think in the file that you have, it's quite easy to see 3 times 10 to the 8 meters per second. That's your value for c. So like c, the speed of light, 3.00 times 10 to the 8 meters per second. And that's not a value that you need to memorize, but it's certainly one that you'll be using a lot. So, I'll always try to provide it for you somewhere on the page. You might have to look around for it. But it'll be there one way or the other. So that's the c that you're going to use. And you're going to use it for these formulas like, for example, c equals lambda nu, which lambda here is wavelength, the lambda for length, so the length of the wave, and that's in meters. And frequency is this Greek letter nu, which I write as a V with a little hook on it. That's frequency. And that's in units of s to the minus 1, also written as per s, so s in the denominator. And it's also named hertz. You've probably seen hertz before. So that's your relationship between wavelength and frequency. And there's a question here about the wavelength of, about the relationship between frequency and wavelength. And it's asking you whether they're inversely or directly proportional. I think you guys know what those two things mean. It's basically inversely proportional. If one thing goes up, the other thing goes down. Directly proportional means they both go up or they both go down. Okay, so you can use that to answer that question. So I wanted to zoom in here for question number 6. You can only see the question here. You can't see your choices the way this is formatted. It's on the next page. But I want to highlight here for you. I don't need for you to memorize the exact wavelengths and frequencies and energies for all the different forms of electromagnetic radiation, but it is helpful for you to be able to rank them relative to each other. So you should know, for example, that ultraviolet radiation is higher in energy than, yellow visible light or something like that. So if you should have a sense of how they rank against each other. You don't need to know the actual numerical values for all of them. We're not there yet. And I give you a hint here that a shorter wavelength means higher frequency, and higher frequency means higher energy. So throughout this problem set, you have to remember these relationships. C is equal to lambda nu, like we were just talking about. And the energy of the light is equal to Planck's constant times nu. Okay, so since there's a set relationship between the speed of light, which is constant, and the wavelength and the frequency, you can always find the wavelength from the frequency or the other way around. You're using the speed of light. Just remember that in the speed of light, those units are meters per second. So your units here are always going to be meters for wavelength, and that reciprocal seconds or per seconds or hertz are going to be your units for frequency, which makes sense, right? When you multiply meters times this weird per second thing, you're going to get meters per second over here. So those are your units. If you don't have those units, you've got to convert into those units, and you'll see some examples of that later. So that's your first relationship, the relationship between wavelength and frequency. Then you've got another another relationship here, but it's between the frequency and the energy. Now there's a constant here. H is Planck's constant, and I give you that value later in the problem set. And so all you need to do is have that value and either the energy or the frequency, and you can find the other. So it's very simple algebra. But again, you need to keep track of the units. The units for energy in this case are going to be joules. I'm going to circle all the units here so you can see them. Energy is going to be in joules. Frequency is going to be in per seconds, reciprocal seconds. And what do you think H is? I'm going to leave that there for you. You'll see it later, but it will make sense. Okay, you follow the units, it will always make sense. So what I want you to see here is I've given you a hint. Shorter wavelength means higher frequency. Higher frequency means higher energy. And you can see that here, that the bigger the number is for frequency, the bigger the number is going to be for energy, because h is a constant value. So whatever your frequency is, it will be multiplied by h, and that will always give you energy. So as that goes up, that goes up. Those are directly proportional to each other. So when you look here, these are your choices. You'll just need to refer back in the PowerPoint presentation or in the online textbook. You can see, or anywhere, you just Google it, electromagnetic radiation, which, by the way, is EMR in shorthand, electromagnetic radiation. And you can just Google that, and you can find anywhere on the internet, you'll be able to find the relationship between these. So you'll see a big spectrum, and you'll see which ones are higher in energy, lower in energy, shorter in wavelength, longer in wavelength, and so forth. And then you'll be able to answer those questions. Okay. Oh, I didn't finish writing that. Electromagnetic radiation is EMR. We'll be using that abbreviation. The rest of these problems are all going to use either c equals lambda nu, speed of light equals wavelength times frequency, or they're going to use E equals h nu, which is energy equals h times frequency, or maybe even both of these. Obviously, these can be used together because they share a variable, which is frequency here. Again, I've just written here the units to help you remember that the speed of light is given in meters per second, and you'll be using that same figure that you used from the previous page, 3.00 times 10 to the 8th meters per second. The wavelength will always be in meters, so if the problem asks for anything else, you're going to have to convert. Like if you look over here, convert meters to nanometers to find the answer. So I'm trying to give you little hints like that, but you've got to get in the habit of always looking for what units do I need to convert in these things. And then these weird slash seconds, it's actually per second for frequency. And on the previous slide, I had shown you for this equation, E equals h nu, I told you the units for E are going to be joules. The units of nu are per second. And I asked you, what did you think the units for h must be? Well, you can see here I've given you the value for h. And if you look at that, look at those units. That says joules times second. Joules times second. And if you look at that, that makes sense, because if you have joules times seconds as your units for h, and you multiply that by this number, which is per second, this second, which is a denominator, is going to cancel with this second, which is a numerator. And then you're going to be left with joules. Okay, and so that makes sense in terms of what the units are. But again, it's always your job to check and make sure that, like, what if I give you an energy that's in kilojoules, then you need to convert it to joules. And what if I give you megahertz? Which one of these is in megahertz? I can't remember. I don't see it there. But anyway, this unit is also named hertz sometimes. And so if I give you megahertz, that means you've got 1,000,000 of them. So you're going to have to do some conversions there. So just keep track of those conversions. So zooming in here to look at problem number 22, this is a multi-step problem, so I want to give you some hints on how to deal with it. It says it takes 254 kilojoules per mole to eject electrons from a certain metal surface. You might remember, I hope you've played around with that animation about the photoelectric effect. I know it's been a while since we've seen it, but when you play around with that, you can see, depending on what metal you choose, it takes more or less energy to eject the electrons from the surface. Okay, so whatever this metal is, this certain metal, it takes this much energy per mole of the metal to eject electrons. Okay, we don't know how much of the metal we have. It just tells us an energy per mole. So we're going to use that as our energy number. Okay, we're just going to have to assume that we have 1 mole of this mystery metal. It says, what is the longest wavelength, and it's asking for it in nanometers, that can be used to eject electrons from the surface of this metal by means of the photoelectric effect. So that sounds crazy and like super advanced. It's really not. You're still just using the exact same 2 equations that we've used so far, which is C equals lambda nu and E equals h nu. Okay. And you've got those values further up on the page there. So what were they giving me here? They've given me an energy, which I'll put in there. Now remember, to use this equation, the way it's intended with this constant, you need to have your energy in joules. Well, they've given us the energy in kilojoules. So you're going to have to convert that before you do it. But once you convert it into joules and use the proper value of H, which is just further up the page, you'll be able to calculate your value for nu, and then you're just going to plug that in here. And you already have the value for C, which is 3.00 times 10 to the 8 meters per second. And then you'll solve and you'll get a value for lambda. However, that lambda is going to be in meters. And you've been specifically told that you want nanometers. So you're going to have to convert the meters into nanometers. And remember, nano means 10 to the negative 9. So in other words, there are 1 billion nanometers in 1 meter. Right, so up here you can see I've actually typed in there the same hints that I just showed you on the previous slide. You see there it says C equals LV. That's actually meant to be C equals lambda nu. I was supposed to format that L as a Greek lambda. But it's the same two formulas that we keep using over and over and over again. These two questions here, 23 and 24, again, I just want you to refer back to that diagram or any diagram you want for the electromagnetic radiation and just get a sense of, like, if I give you 2 or 3 different types of electromagnetic radiation, I want you to be able to tell me which one has more energy and which one has less energy, or which one has the longer wavelength and which one has the shorter wavelength. Again, you don't need to know the exact numbers, you just need to know, like, how they rank within each other, okay, with respect to each other. So that's what those two problems are about. And then here, these two problems are about the diagram that showed all the different energy levels and electrons either going up or going down between those energy levels. And the N tells you what energy level you're on, okay? And these are transitions. So in letter A here, you're starting at level 1 and going up to level 6. In B, you're starting at level 6 and going down to level 1. So pay attention to whether you're going up or going down, because if you're jumping up, the electron absorbs energy. If the electron is falling down, then it releases or emits energy. And this question, I believe, yes, emission. So this is talking about emitting energy. So you want to choose which one of these journeys for the electron is going to release the most energy. Okay, so that's what that question about. Again, you don't need to know anything about the numerical values to answer that question. Now, number 29, you do need to use an equation, and I've tried to give it to you there. This is the equation that you can use to calculate the amount of energy that's either absorbed or released during an electron transition, okay? And you'll see there's a negative sign there in front. That's a constant value that you always have out front. The energy will be in joules, okay? The energy is in joules. And what I have here is 1 over n squared minus 1 over n squared. This n is the final n, your destination n, and this n is your initial n. So I've told you here that we're looking for the value of energy for the electron, and n equals 4. That means we're assuming that it falls from level 4 to level 1. So your initial is level 4 and your final is level 1, and that's what you would plug in to get your answers there. Just math, and I think you can do that. Okay, and these are the final two questions, and they're using the exact same formula that we were just going over on the previous slide here. Exact same formula there. However, you'll see there's a twist here on the last question, because it says the frequency of electromagnetic radiation required to promote an electron from level 2 to level 4. So we're going up. That means the electron is absorbing energy, okay? They want you to tell the frequency of the electromagnetic radiation required to do that. Well, you've been doing energy with this equation, okay? This is all about energy so far. Well, no problem, because you know how to convert energy to frequency, and that's using our old favorite equation here, E equals h nu. And I've just reminded you, there's the formula E equals h nu, and remember the value for h is this, okay, this number here. So you don't have to go back and look it up. But anyway, what that means is before you can tell what the frequency is, you have to use this equation to calculate your energy. Okay, and I've given you the values of n there and then the value of the constant. So use that to calculate energy, then use that energy and the value of Planck's constant to get your frequency, and the answer will be in hertz. The answer that you get will be in the proper units. The reciprocal seconds, those are the same thing as hertz. All right, so then you have all of them done. I know this video is quicker than the other one. It doesn't have all the detail, but that's because the math is not difficult math. It's just straight up algebra that you guys should know how to do. Hopefully this has been helpful in setting you up with the concepts and the structure to do all these problems. Let me know if you have any questions.